Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. FYP2 is watching this recording for final year project presentation. Okay, my name is Tuan Nuramirul bin Tuan Mahmud 1625375. My topic for final year project is lab scale physical modeling of commonly used for drainage, for road drainage inlets. My supervisor throughout the completion of FYP is Prof. Abdullah Al-Mamun. Okay, first and foremost, for the introduction, I would like to highlight my topic focused on studying the common road drainage inlets. Hence, I needed to construct the prototypes as lab size to fit with the hydraulic lab equipment. Next, the problem statement, as the topic was completed in order to figure out the modest road inlet in lab size for the first one, then is to carry out how the application of an inlet is in terms of capacity or capability and etc. That's related. Okay, then the objective of the project are to study the rainfall intensity relationship to establish, in order to establish the commonly models of road inlets in physical lab size. And the last one is to figure out the hydrology knowledge related with them. Okay, for some briefly methodology, as the lab work experiment were done to collect some parameters of data, such as water depth and outflow discharge of an inlet, plus the selection and assembling the road inlets models. For the inlet selection, I had selected the circular, rectangular, and also the grid types. The materials that been used are plastic boards, PVC pipes, and another few things. All right, for the literature review of this study, some listed keywords were explored, such as rainfall intensity, hydraulic structure, like VS and general concept, discharge capability, discharge coefficient, steady state flow, and etc. And then for the detailed methodology, the first phase was on the FYP1, which focused on research activities. Then second phase and third highlighted on selecting the inlet, constructed them, and also the lab activities. Then result and the last one were analyzed as the part of the project. Then this is some of actual inlet when I did some site visit around IUM, yeah, circular, rectangle, and also with grid. Then when I need to change to lab size, this is some of my prototypes. For the prototypes, I scaled down the size to be around 1/5 of the actual size. Okay, next, the important equipment used was rain simulator, as the inflow rate could be set by the meter, and the rain simulator can be used in a hydraulic lab. Next, this is a short of procedure during the experiment. The inflow rate was manipulated to a few readings for all inlets. To see the comparison, the 4 sprinkles were used, so area covered by the rainfall around 0.25 meter square for total. And after that, discharge water was collected at 10 seconds consequently for 3 times to get the average. Lastly, depth of water around the inlet also measured. Then we move to the result and discussion part. At the first one, rain intensity was calculated by converting the inflow rate. Then calculated inflows was obtained by using rational method. Because we are using a specific area, then the outflow seemed to be proven with inflow from meter. After getting all the parameters, some calculation were done to make analysis. Water depth was measured to study the difference influenced by different types of inlet. Next, from the grade, for the collection of data, this is the sum of how the collection of data was recorded. This is depth of water throughout 3 different inlets. It shows varied in a few for different types. Okay, so from the table, I had construct the graph. What I can conclude that Great Inlet got the highest water depth accumulated near to the inlet, then circular and rectangular. This is because the position of the Great Inlet itself is put on the ground, which is horizontally. So water would channel 100% through the inlet. Moreover, the opening size of the inlet was smaller compared to others. So the capability and also the capacity for the water can flow through it quite limited. For circular and rectangular inlet, their position will bind to the root curb, for example, or as it is put in vertical position. So water could flow through them freely as long as the water was not over height of the inlet. That's why the depth of water for Great Inlet is more compared to others. Okay, next analysis is on the inflow and outflow rate. From the result here, the inflow and outflow seem to be same. For a real situation of floats, basically many roughness should be considered. But then for this prototype, we didn't consider at all for the roughness equation because the platform is smooth. But then what I can conclude is runoff might take some time to enter inlet if in reality. Okay, next, the other analysis is on the calculated outflow for each inlet. For this section, flows in channel and wheel formula are used to justify the discharge. For circular inlet, perimeter of water depth and diameter of opening are vital to find out the discharge. And then for the rectangular and Great Inlet, as their opening shapes are similarly same, so I use a Rehbock formula. Okay, the next result of the calculation proven that the error between measured and calculated below than 10%. To be honest, some numbers are beyond that, but I may conclude the human error were done when collecting the data. Last but not least, for the part of analyzing, another parameter which is discharge coefficient was determined. Discharge coefficient, or CD, is the ratio of measure against theoretical discharge. It related to the steady flow with same shape. Rectangular inlet was selected to prove the theory. So discharge coefficient basically is determined from two different equations, which are conventional and also the Hamilton-Smith. Right. Both analysis give small difference which prove the both equation. Then the discharge coefficient for the particular inlets can be concluded around 0.6 to 0.65. Okay, the last part is the conclusion and the recommendation. Throughout the lab work, conclusion that could be made is size of opening and also the inlet shape as well as the position horizontally or vertically. Then hydraulic elements discovered are the steady state flow for the lab work without considering the many roughness equation. So we can see that the inflow rate and also the outflow, it seems the same. Next, for the recommendation that I could give, my recommendation for the next research if relatable, try to consider the element of slope roughness and others that is related to, because they are one of the parameters throughout the equation to find the respective total discharge. And also explore the inlet capacity, efficiency, and also spacing as in MASMA for our manual in Malaysia had established the guidelines. I think that's all for the presentation. With that, thank you.